First, I'd like to thank the organizers for inviting me. I'm really excited to be here for kind of irrelevant reasons. One of my hobbies, my personal interest is in sacred vocal music, and I've become fascinated with William Byrd, who was Queen Elizabeth's court composer and her favorite composer. He was a closet Catholic, well, not so closet Catholic, and it's a fascinating story. And he was very good friends with many of the Jesuits who were, suffered some bad fates at that time. And he actually was born in roughly the same year, I think, as Edmund Campion, who was a Jesuit. Correct me if you know the dates better than I do. And we see they had very different fates, and it's a fascinating story about how Byrd managed to keep his head on his shoulders and even get retirement gifts from the Queen. So, and I do have a screenplay, and anyone welcome to produce it. And the bartenders in the bar are going to play the lead character, so we're all set for that. Okay. Okay. Well, actually, originally, can you? Yeah.
Is this connected with translation, with transactional interpretation?
William Byrd.
One will have his head chopped off.
That's a. I can write a paper about that. Yeah, that's a good idea. We'll just post-select for William Byrd. I actually changed my talk around a little bit. I was going to mainly focus on issues of free will in a block world and what that would mean and whether we can have it. But there were so many interesting talks and obviously a little controversy concerning the two-state vector formalism and of course I am an advocate of the transactional interpretation. Slightly different form of it than its originator, John Kramer. And so, you might be wondering, well, why is she, sometimes I'm kind of playing devil's advocate and challenging the two-state vector formalism folks to kind of explain themselves in certain contexts and saying that I'm not so convinced that formalism is the best way to see things. However, I just thought that it might be useful to kind of focus on this issue of these two interpretations, which seem like they should have a lot of overlap, both involving some form of retrocausality, at least in a formal sense. So I was going to focus on those two things first, and just kind of by way of doing that, I think you've had enough of an introduction you've seen the basics, if you didn't already know already, of the two-state vector formalism. So I was just going to do a little bit of review on the transactional interpretation and my proposed broadening of an extension of it, if you will. And I just wanted to note that my version, which is called possibilist transactional interpretation, is a realist theory. I take it to be referring to something ontologically real in the world, but it's novel or different perhaps from the way the term ontological interpretations or realist interpretations are usually used, where those generally involve beables, elements of reality, hidden variables that one can analyze. My version does not have anything like that. Instead, it does take quantum states as physically real entities of some sort that are sub-empirical, and I do propose that there's more to reality than the space-time manifold, and that's what quantum states are. In a sense, they are something that can be part of a process of becoming, where these interactions are leading to space-time events but are not actually contained in them. And also, I thought I should just, since I'm talking about quantum states as being real, I felt like obligated to justify why I'm still thinking that way in view of David and Matt's interesting result. My half-baked comment on that is I'm not really convinced, and I do think that if you can ease that restriction that was contained, I unfortunately don't have the reference, but David referred to a reference back in the 90s, I think, where some results were obtained of what you can say about various kinds of ensembles, and I think those results were valid for a restricted kind of situation that didn't take into account these pre-entanglement phenomena. So that's my justification for going ahead with this, as opposed to just saying, okay, I give up, and David was right. Okay, so this is just a very brief overview of the transactional interpretation. It's based on the Wheeler, Feynman, and Davies direct action theories of fields, in which the basic field propagation is time symmetric, and there's an absorption response that plays a crucial role. So in TI, the usual quantum state that is just, the one state picture, it is not the whole story, but it is part of the story, and it is what is emitted by an emitter. That's how those quantum states come into being, is they get emitted, and that's what's emitted, this offer wave, which is represented by the usual quantum state, forward directed. So then you have, because this is a direct action theory, it has a response. The absorber always responds in a certain way. The response is called a confirmation wave, and it's an advanced state. It has negative energy, at least at the non-relativistic level. An advanced state is described that way. So these two waves interact. It's like a handshake, which was Kramer's original picture. Now, in my version, I think this process is going on in a sub-empirical sense beyond space-time. In general, one offer wave will generate several confirming responses from different absorbers. Each of these sets up what I call an incipient transaction. Then one of these is actualized, and at that point you have a real transfer of energy in space-time. This has now become something that's happening in space-time that is really emitted and transferred from the emitter to that absorber that participated in that winning actualized transaction. Now, the neat thing about all of this is that it does give you a nice physical basis for von Neumann's process 1, or the measurement transition from a pure state to a mixed state. And then after that point, there's sometimes another second part of this process 1 where the collapse would then be the selection of one of those pure states from that set of mixed states. So this is just kind of a picture of what that looks like in the direct action theory. And if you look at the emitter, I guess I should be pointing things out here. The emitter is emitting an offer wave, but it's a time symmetric field. So the offer wave, what we think of is really this part, just this part. But there's another component. Both of these are half the strength of the usual picture of an emitted field. So half the amplitude of the field is going in the future direction. Half of it is an advanced state from the emitter. Then, when this component stimulates the absorber, it will respond exactly out of phase and emit its own time symmetric field, part of it retarded field going into the future, and part of it this advanced field, which is the confirmation. But the neat thing is, because, and you have to pick boundary conditions, any time symmetric theory, in order to get something asymmetric out of it, such as the kinds of energy flow we see in one temporal direction, has to have boundary conditions that will create that asymmetry. And this particular choice seems to make the most empirical sense, and this is the one that you always see in connection with these direct action theories. And in this case, what you get is cancellation. The two fields cancel so that beyond the absorber there's no further field, and preceding the emitter, this field is this advanced component is also canceled out. And of course the field in between is reinforced, so that what you end up with is a full strength field from the emitter to the absorber. Now, this particular picture only shows the one absorber context, so there's no competition here. All of the offer wave is being absorbed by that one absorber. Okay, so that just kind of shows the transaction that becomes actualized, and the result being that the energy in the emitter is given up, and the emitter loses energy, the absorber gains it. And this provides a really nice account of, this was actually Feynman's motivation, is that it provides a much more natural account of the radiative damping and those kinds of phenomena that are needed in order to account for why an accelerating charge actually loses energy, because that's an asymmetrical process, and it's very hard to get that without, as many of you know, I'm sure, in the standard approach, you have to just assume an ad hoc free field to get this thing to work out. Okay, so we get two things from this. We get that building up here of these two components to a full strength but it's also a real field where these two original fields were complex. The complexity goes away and you get a real field, which is a nice way to understand the non-space-time or the extra spatiotemporal waves, if you will, coming into being in space-time because their complexity has been removed and they are now real quantities that could be understood as inhabiting space-time. And then the second part, when you consider the amplitude of these two fields, you automatically get the Born rule out of that. And that, there's more I can say about that, but in the interest of time, there are plenty of papers and references on this that you can see more about where this product comes from. But it's basically the amplitudes of the offer and confirmation. Okay. Okay, so this is just a specific example of a typical situation where you'd have more than one absorber responding to a given offer wave. What happens is that the individual components will be attenuated by the various things they're interacting with, so that when you have this component along this arm C and this component, and they're each going to different absorbers. So each of these absorbers is responding, receiving only a diminished, attenuated version of the original offer wave, so they're each receiving their own component, and they're responding with an identical but a conjugated version of that, the adjoint of what they received. So the responses look like, I can't see this too well, but I've written in there the confirmation responses, which you've got a bra with a complex conjugate amplitude. Other than that, they're basically mirror images of each other. So what you get then, you take these two things, the offer wave component and the confirmation for each of these cases, and you see that their product just gives you a projection operator corresponding to the result of having gone along arm C, weighted by the Born rule. So it's just a nice way to see, if you like this account, or if you're willing to consider it, the payback is that you get a very nice physical referent for the Born rule and also for von Neumann's process 1. Because what we get then, and if you add more absorbers, you have more components, each of them responding with their own mirror image. So you end up getting this sum of weighted projection operators, which is just your mixed state that you magically are supposed to get along as a result of measurement, which von Neumann observed and formalized this way, but there was no reason for that. So that's why the transactional picture appeals to me. I feel that it gives a very nice physical understanding of these processes. Okay, but not all of these incipient transactions can be actualized. So then we get into, the collapse thing, what's happening here. One of these is being selected. We don't really have a particular reason for it. And I take this as a kind of analog of spontaneous symmetry breaking. I mean, we do have spontaneous symmetry breaking in physics. It's fairly standard in the Standard Model and the Higgs mechanism and so on. We often feel dissatisfied with the idea that we can't give a sufficient reason for the actualization of one outcome where the others aren't. But it apparently happens, and it's something that nature seems to do. This case, you have weights, so that not all the different outcomes there's not an equipartition of the probability. They in general can have different weights. So we have a weighted spontaneous symmetry breaking. And this kind of ties in with free will because I'm going to talk about this a little bit later, but to me this seems like a natural place for the notion of volition to come into the picture. We don't have a sufficient mechanical, causal, law-like reason, if you will, but something happens, and so perhaps this is a way for volition to enter. So these are just some references if you want to, I've gone through this very, very quickly here, but there are more details in these papers that describe how I've worked on developing Kramer's original picture. I felt that in view of things like multi-particle states, which have many more dimensions than you have in space-time, I didn't think it was realistic to try to think of these objects as being space-time objects. perhaps we can think of them as having projections on space-time in some sense, but that's why I kind of embraced, hey, you know, the idea of there's just more out there, more physical reality out there. It's just sub-empirical, and because it's not something that fits into space-time. The last I heard from John Kramer, he was still thinking about this picture. I don't think he's really enthused about it, but anyway, maybe someday. There were also some discussions about how, you know, another outstanding problem is accounting for the emergence of classicality, the emergence of the macroscopic realm. This is something I've worked on addressing. I think I'm coming up with a fairly plausible account, but you have to go to the relativistic level in order to do this. So there's a reference for, it's one of these papers. It's the Foundations of Physics paper, the second one there. And that's also, material is also in the book. That if you look at, if you consider the idea of coupling amplitudes as, among fields, as amplitudes for the generation of an offer wave and for the generation of a confirmation wave, you know, you get to the domain where these may not be assured, and you have to take them as uncertain. So there's like an additional subtler level of uncertainty. But if you consider that, you consider the fact that macroscopic objects are conglomerates of many of these objects that have these coupling amplitudes, you start to see a basis for having the macroscopic world emerge. Again, don't have time to go into that there, but I do think that this is still a difficult issue, and I don't think it's been solved within an Everettian account. The idea of Ein selection of pointer observables and decoherence that is often referred to as quantum Darwinism. I've recently written something pointing out that I do think it's circular, and I don't really think that gets off the ground. So I think that's something that we still need to think about. Okay, so now I'm going to consider the overlap, if you know, see how much overlap there is between the two-state vector formalism and the possibilist transactional interpretation. Well, we have some areas of commonality. Both TI and TSVF involve something more beyond the one-state formulation of quantum mechanics. They both make use of advanced states, although in different ways. They are both empirically equivalent to standard quantum mechanics. There's a little caveat there. There may be a possible small deviation at the relativistic level between the possibilist transactional interpretation and standard QED. That's very speculative, though. But for purposes of you know, all the non-relativistic types of experiments and situations we want to talk about, both TI and TSVF are just different formulations of standard quantum mechanics, and they are empirically equivalent. And of course, the founders themselves have noted this, and that they are empirically equivalent. So just a remark here that's why, you know, FS seem to be making trouble every now and then with my questions. It's that you know, whenever I hear someone saying, "Oh, look, here's an experiment. We've demonstrated retrocausality. We've demonstrated that you need the two-state vector formalism." Well, you know, that I really have to kind of object to, because they are empirically equivalent. So no experiment that you can do can discern between the transactional interpretation, standard one-state quantum mechanics, the two-state vector formalism, you know, any other interpretation. They're all empirically equivalent. Now, I do understand that there are other considerations, such as the heuristic utility of looking at the post-selection, the idea that there's a simpler account, perhaps. I think that's debatable, and that has problems too. But you know, I definitely can understand the spirit of wanting to take into account the post-selection. You know, does that contribute to understanding more about what's going on? But you really can't say that any given experiment confirms or corroborates one of these over another. Okay, so there's another commonality that I thought was a piece of common ground, but on further reflection, I had to kind of question that. Avshalom was noting in his talk that he saw the idea of, say, in an EPR experiment, having the pass be sort of empty in a way, and then pending what your measurement result was at some point, that retrocausal effect that he thinks maybe happening from that post-selection measurement fills in the empty past in a sense. And that's actually something that is part of the PTI picture, in a sense that there is a subtle sub-empirical retrocausal influence from confirmations that bring about past events in that sense. But then I thought, well, wait a minute, I'm not sure that really could be part of the two-state vector formalism, because if you do want to say all quanta are always described by the two states, then it seems to me, and maybe I'm missing something, but it seems to me that kind of forces you to have a block world where all future measurements are already there. Because if you don't, then you can't define any of those quanta because they don't have post-selection states, and you cannot define the two-state vector for them. So, you know, and as we heard from Ellie and Lev, they do want to talk about future measurements. So evidently they think of future measurements as being out there in the future, you know, already, if you will. It's so hard to talk about these things, you know, but that the future is laid out, and that all quantum objects are correctly described by their preparation, their detection, and up till the end of time, or, you know, whenever, you know, whatever's happening in the future, and I don't know. But it's all there, and so that's my understanding. I could be wrong, but it seems to me that the two-state vector formalism forces you into a block world picture in this way. So the point being, maybe what Avshalom has in mind is really the transactional picture. So, okay, so areas where the two interpretations diverge. In TI, the advanced state is a separate entity. It's the confirmation. In possibilist TI, both the offers and confirmations are pre-space-time entities. It's only the actualized transaction that establishes space-time events. In contrast, the two-state vector formalism takes, my understanding is it takes these vectors as real things that exist in space-time. And now, from the point of view of the transactional picture and the direct action picture of fields that it comes out of, two-state vectors really can only be offer wave components. That is, they are just like in the interferometer picture, they identify a portion of the offer wave that went to one of the detectors, and the other two-state vector is the one that went to the other detector. So those would not be the whole story according to the transactional picture. It would just be an identification of an offer wave component according to its attenuation and the fact that it was emitted with some kind of preparation and then detected in a way that attenuated that original emission. And then, sounds like an advertisement. So again, number 4 is that it seems to me that TI does give a straightforward account of the Born rule, while it looks to me like the two-state vector formalism just has to assume it. The other distinction is that PTI involves a pre-spacetime sub-empirical retrocausation only, while the two-state formalism asserts that retrocausation occurs within space-time, as I understand it. So number 6, in PTI, there's a growing universe, where, as I said before, the two-state vector formalism seems to imply a block universe. Okay. All right. So again, from the point of view of these kinds of theory...
I wish you could wait.
Sorry.
Go back to...
Yeah.
Yeah, just finish waiting.
Did I... Okay, there's a lot of stuff on here. Okay. Shall I continue? Okay. Okay, so again, from the point of view of the direct action picture of fields, which is a pretty well-developed theory, I mean, different forms of it. There is a QED form of it, and that's by Davies. It would not be consistent with those theories to just combine the retarded solution to the fields and the advanced solution into this hybrid entity. That sort of just doesn't really it's not grounded in a well-defined theory of fields and their propagation. However, in TI, the retarded advanced solutions are fundamentally distinct, even though they can and do interact. Okay, so back to this question again. I'm kind of repeating myself a little bit, but just to get maybe clearer on this point, isn't the transactional interpretation retrocausal? And again, it's only at a pre-spacetime level. So the idea is that offers and confirmations bring about space-time events from that pre-space-time domain of possibilities. So any kind of retrocausal influence that's dynamic, that's truly dynamic in nature, is not something that's happening within space-time. Rather, it's part of the process by which space-time events are created. And I talk about this in my book. So therefore, PTI does not have explicit retrocausal effects within space-time, and therefore it does not have to be a block world picture. In fact, it's explicitly a growing universe picture. Okay, so that's kind of the preliminaries of the comparison between these two theories. So now, having thought about the idea of whether we have a block world or not, and whether if we do, what kind of causality, what sort of notion of causality do we have to think about? Again, a very non-trivial, difficult problem that I'm not going to solve in this talk, but just want to acknowledge that I enter these kinds of discussions with great trepidation, because I know what an elusive concept causality is, and very hard to define. And of course, Hume said that's because it doesn't exist. So maybe he was right. Okay, but so let's get to some basic definitions in the literature, the traditional and more recent literature on free will. There's a theory called compatibilism, which I'm sure a lot of you already know this, but just to kind of lay it out. The idea that free will is compatible with determinism and or a block world, not just sort of forward developed determinism, but the whole idea of a block world. And I know a lot of folks here are compatibilists. And I apologize if I'm having trouble fully understanding your view, but I'm gonna try. But anyway, okay. So call me on it if I'm oversimplifying it. Okay. So in compatibilism, which is what I kind of understand, the idea that free will is incompatible with determinism, and that it's also incompatible with an indeterministic block world. So a specific angle that you can take on an incompatibilist approach is if you can either say, therefore we don't have any free will because it's a block world. That would be an incompatibilist. And there are a lot of folks out there doing that right now, and they call themselves optimistic disillusionists. Let's see, it's Greg Caruso, I think. And they say, yes, physics tells us either that we live in a block world or that it's fully deterministic, and yes, we have no free will. And isn't that great? Because we don't have to be angry at each other for doing immoral things, because nobody's responsible, and who we can let go of these morally retributive attitudes, and it's great. So, okay, I don't agree with that. But anyway, that's one approach. I have a different approach. I'm an incompatibilist, but I think we do have free will, because I do think that we don't have a block world. Okay, so that I would call myself, I guess, an agent causal libertarian, that I'm going to kind of defend here. So from the literature, and there are many important contributors to this, and I'm just kind of cherry picking some of them. Genet has a formulation of an incompatibilist argument called the consequence argument, and it goes like this: no one has power over the facts of the past and the laws of nature. No one has power over the fact that the facts of the past and the laws of nature entail every fact of the future, i.e. that determinism is true. Therefore, no one has power over the facts of the future. So thus, he is refuting compatibilism, because the idea is that if you don't have any power over anything, it's not up to you whether anything happens or not, then, how can you say you have free will? And as against some compatibilist arguments, just being ignorant of those choices in the future that are already there that we are obligated to make is not equivalent to having free will. So just another way to look at it, if the laws or events or conditions that obtain require all those events, and they are not dependent on the agent, and those conditions are met, then the agent is not the free cause of those events. So in this sense, a block world picture rules out free will, because again, and it's not deterministic necessarily, we could have an indeterministic block world. But even in the more general case, that's a fact about the world, that there are events and conditions that obtain without any input from any agent participating in those events. So once again, at least according to that definition, such an agent doesn't really have a robust form of free will, because it's not up to him whether these events occur. And there's a possible exception if agents are seen as bringing about space-time events from outside space-time, that they can somehow intervene, and their mental life lives beyond space-time in some sense that allows them to actually intervene from beyond space-time, then maybe that's an exception to this argument. So again, we've got some dominoes here. God has knocked over the first one. They are situated in such a way that the laws of nature dictate that they're all going to fall down. You don't need to ask any of these dominoes, what would he like to do? You just, So the dominoes might discuss amongst themselves, okay, I'm not going to fall, or whatever, and just sitting there and saying, oh, I have free will. Well, no, it wasn't up to him. He's going to do what he's obligated to do. So this just a little... summarizing here that as a libertarian would argue that events are neither deterministic nor fated, and that therefore there's at least an opening for free will because we have this fundamental indeterminism. Now, of course, there are various demands for an adequate libertarian account, and I'll have a few comments about that. And of course, there are various objections to this claim that you can have effective free will even in the face of indeterminism. Okay, so there's something called, that is referred to in the literature as the Common Thesis against libertarianism. This is the idea that a libertarian is necessarily committed to the idea of lawless action, that because they want to say they're not compelled to do anything, they're not governed by any law, and therefore that you must have this anomic or lawless action. And then there are some counter arguments to that claim. There's some things in the literature where people have taken various avenues around that and have good responses to that. So it's something you can question. And I'm going to kind of focus on one way of countering that argument. First, by noting that some libertarians have kind of let themselves be put into a box, by saying, well, I can give reasons for why I made my choice. I'm not, there's no anarchy here. And they're trying to give a nice causal reason-based account. But of course, once you do that, you start to question, well, are you being steered by those causes that you've cited? So I don't think that's a good way to go. There's one famous challenge that's called the problem of luck, which is basically just, I find that I'm really underwhelmed by that alleged problem, because it just seems like it says, well, you've got in one world, two different possible worlds, both having the same sequence of events leading up to a point, but then there are two choices you can make that will tell you which world you're going to end up in. And it's just a matter of luck which one you end up in. But to me, that's just volition. That's the whole point of having volition, is that you can say, I'm going to choose this world. So maybe I'm missing a subtlety there, but the whole point, though, of those kinds of arguments is that it's sort of implicitly assuming the principle of sufficient reason. That you always have to have that part of the assumption that the libertarian has to be able to give a sufficient reason for his or her choice. And I'm going to say, that's just wrong. The whole point of, sure, it's nice if you can give a reason for your choice. But ultimately, when it comes right down to it, the key seed, the key vital essential element of free choice is volition, which is fundamentally uncaused. And so you should be able, as a free agent, to say, arbitrary, capricious choice, I'm just going to do this. And you can call that lawless if you want, but we'll see that it can actually conform to various laws. So here's an example of a free choice lacking a sufficient reason. The example of Buridan's ass. This is a classic satire of this whole idea. Now, I think he would just grab a bundle of hay and start eating. I think he'd just do that. So it's I wish we could do the experiment and see what happens. Okay. So no sufficient reason. He's just going to eat. He's just going to do it because he can. All right. So the essential point about volition, I claim, is the ability and power to make a completely arbitrary choice for no reason at all. I don't know if any of you have seen and now I'm going to reveal my geekiness here, science fiction geekiness. Babylon 5, the TV show Babylon 5. Anyone? Anyone? Okay, at least 3 people. There's a very dark part of this show where one of our heroes has been taken prisoner by this evil emperor, and the emperor gets annoyed with him because he's looking at him, And so the emperor says, "I don't like the way he's looking at me. Pluck out his eye." And so one of the guards says, "Which one, sir?" "The left one." And that's what we're talking about here. Sorry for the really, morbid example, but just, there's no reason there. You just do it because you can, Okay, so that's kind of spontaneous symmetry breaking. That's why I kind of think of that as a volitional type of phenomenon. And I don't know, you might argue, well, I think it is lawless. I think, especially when you talk about things like evil emperors, it does seem kind of lawless. But we'll see that, I think, I'll have an argument that even though at that particular decision point, you may have that anomaly or that lawless kind of phenomenon, overall, you're not really going to go astray from the relevant laws. Okay, so now here's the other argument, originally due to Sider, 2005, I believe, that, suppose we really do have free will, the universe is indeterminate, the future is undetermined. People will argue, Sider argues, that still, that kind of causation has to conform to the quantum mechanical probabilities. So in a sense, you're a slave to that. So, how good is that account if you're a slave to that? So the idea is basically, look, if you have, an ensemble of people all making a free choice, wouldn't it be a miracle if they all happened to choose in such a way that ensemble obeyed the quantum statistics? That's the argument there. How am I doing on time?
We have 20 minutes left, including questions.
Okay, thank you. Okay, so there are some responses to this. Clark has an interesting argument that an agent can still freely choose, even under this kind of probabilistic constraint. I don't really have time to go into it here, but he proposes kind of psychology experiment where a subject is told to push a red button or a blue button, and each choice is free, but you must distribute it so that there are 40% blue button pushes and 60% what was the other color, red, and that agent can choose to conform to that distribution, although each one of the individual pushes is free. So he gives that kind of story. So I want to kind of examine this a little bit further and propose something that may seem a little bit outlandish, but bear with me. Okay, so going to the land of the quantum dominoes, very poorly constructed god of the land of the quantum dominoes here decrees that whenever one of my subjects is struck, he has a free choice of whether to fall or not. However, each has a 50% chance of falling, and they must collectively demonstrate that by a frequency of 50%. Therefore, if all my subjects are struck, only half of them should fall. Okay, so the paradox here again, if each domino has a free choice, doesn't this imply they could just all fall if they wanted to, thus violating the god's decree? So in a sense, isn't it self-refuting? That's Sider's objection. And on the other hand, if each just happened to freely choose so as to conform to those statistics, wouldn't that be a miracle? Well, I'm going to argue that maybe not. Maybe that wouldn't be a miracle. Okay, so again, since we're talking about quantum laws here, why don't we consider the individual dominoes as having to kind of cooperate amongst themselves, but maybe not in an overt way, but maybe in a kind of subtle way that is really analogous to quantum steering. So we can represent each domino by a quantum state, which is consistent with what the domino god said about their individual probabilities, and you can have this be a kind of a computational basis that's justified by the physical situation. where their choices are taking place. So let's just consider, if each of them has this state, let's consider 3 of them, and we'll just look at the combined state, and we'll see that they're all entangled. So we can, see, well, what are the possible outcomes here? If you got 3 dominoes and 2 of them make their choices, then we'll see that the 3rd domino ends up being steered more to one choice than another based on that entanglement and the fact that the fellows have kind of picked a particular, narrowed down which states apply to the group. So there's a kind of steering, and nevertheless, so you can think of that as a kind of a peer pressure or something that may make it harder for the remaining domino to choose one or the other, but he still can. You can make an effort of will, maybe to a harder effort of will, a greater effort of will to choose the option that is less likely. So an example would be, sometimes it is, with our own experience, we can kind of feel that sometimes it's hard to make an effort of will and carry out certain actions, and this is a real case example of my having thought I lost a book and then found it 10 years later, and definitely a hard choice to go back and pay the library fine. So, okay, and these are just, you can probably see how it works, but this is just looking at some specific states. If you want to look at the probabilities, say that the 3rd domino, the 3rd in a row there, will choose to fall, then you're looking at the relevant states, which are the 1st, 3rd, 5th, and 7th state here. And then if the 1st and the 2nd domino choose to fall, then all we have applicable for the 3rd choosing to fall is that 1st term. And so his probability of falling in that context is only 25%. But if one of the other ones chooses not, at least one of the other ones chooses not to fall, then his chances of falling are much greater. So in a sense, it's easier for him to make that choice. But the point is basically he's still making a free choice, and he's being steered. So that's my proposed solution to that argument that, are we a slave to the quantum statistics and therefore do we not have free will? Well, we're pressured perhaps, but not sure that rules out the idea that we have free will. So this is, kind of a summary that there are no obstacle to free will, the quantum constraints, but they can be seen as influencing the likelihood of an agent's making a particular choice, in effect requiring different amounts of effort to make those different choices. So this is a little bit of an outlandish picture perhaps, but there are intimations of this idea if you want to kind of, if we're dealing with phenomena and entities that might be beyond space-time, we might be willing to entertain other elements of a sub-empirical reality. And it is reminiscent of the idea of a collective unconscious, Jung's collective unconscious, or the aboriginal dream time, a place beyond time and space. The idea that every person essentially exists eternally in the dreaming. And the idea of an eternal realm is really a lot like what this realm of possibilities would be, because if it's not within space-time, then in some sense, you can regard it as eternal. Okay, so as a recap here of this comparison between the transactional interpretation and the two-state vector formalism, just noting that there is a form of retrocausation in the transactional picture as I've developed it in the possibilist ontology, but it's not retrocausation within space-time. So in that sense, it does have a lot in common with Avshalom's notion of filling in the empty past. And in my work that I'm working on now, I'm trying to give a more detailed, a clear account of that process. Basically, whenever you have, say, if you have sense organs that are absorbers for offer waves, anytime there's an actualized transaction between some source, some light source, the sun, and your eye as an absorber, and of course your brain is in there too, but that the actualization of that transaction that conveys real energy from the sun to your eye and in turn to your brain defines the now for you. It's a local concept. This picture has idea of the now that is not like a line of simultaneity or anything like that. It's a purely local concept. And at that point, the past has been filled in for you where it didn't exist before. So there are some things leading up to that point, if you will, where there was kind of an empty space-time, and that upon actualization of that transaction, certain events are brought into being, and the emission is an event that's brought into being. When it's brought into being, it's already in the past. So in that sense, there is a kind of reaching back into the past, but it's not a reaching back that is confined to space-time. It's simply a kind of a dropping into space-time, if you will, from a domain that's beyond it, and then localizing events in their place in space-time. So I think that this picture lacks the tension of the two-state vector formalism, which wants to talk about causality, actually in both directions. It wants to talk about forward causality and retrocausality, but yet there's a block world, and I don't see really, it seems like it's a superfluous idea to have causal notions in a block world where all the events are already there. And in fact, this is the view of the relational block world proposed by Michael Silberstein and, I forget his first name, Mark Stuckey. And they have a picture in which there's a block world. The events are defined by their relations. And you can think of relations as causal perhaps in some sense, but there's nothing dynamical going on. And I don't agree with their interpretation, but I think it's self-consistent, and I do think they're right that if you have a block world and you have certain events, they do have relationships to each other, and they depend on each other in that sense, but they aren't causing each other because there's no room for any causation. There's nothing dynamical going on. Everything just is. It's a static picture. So that's my big concern about trying to talk about retrocausation or even forward causation in a block world. I think this is where we need to look more closely perhaps at what we mean by causation. Do we mean something dynamical? Now, I was talking to Phil Dow, and he thinks of causation as simply relational. So, there's a lot of work to be done, I think, in figuring out what we really mean by causation before we even get to the issue of, or do we have any retrocausation? Just this one last thing, that the transactional picture is based on those well-developed time-symmetric field theories, while it seems to me that the two-state formalism deviates from those theories. Now, to me, it seems like an ad hoc deviation. People who have formulated it may not feel that way. But it's a kind of entity that has a singular entity that has causality going in two directions at once. And I don't see like a well-developed theoretical basis for that in field theories. Now, there may be one that can be constructed. It doesn't seem to me to be the most natural way to go. Okay, all right, so, and this is the book where I talk about my possibilist development of the transactional picture. It's available down the street. Let's see, I guess I have some other things I could go into, but I guess this probably...
We are rather short.
Okay, so I'll just stop there.